So I have posted the practice problem. You all have seen it, I assume. So work on it on your own, and if you have a question, you can come to the help session. And then there are 2 pages before the test practice problem. Read them. The first page is just very general suggestion of how to tackle the test, like read it front to back, allocate your time accordingly, and start with the problem that you're most comfortable with, things that you probably learned from your freshman. And then please don't leave any problem unanswered, because I can't give you any credit. So the minimum right now, I'm going to use continuity. Or if we run out of time, I'm going to use continuity, and I'm going to use that to find the velocity, and then by the time I'm going to use the Bernoulli and get the pressure, and I use momentum to get the forces. Just that few description get you half the credit. Right? That makes sense to you? Other than that, it's all self-explanatory. You can read that yourself. I don't think I need to go over that. Then the second page is the review, which I have done mostly the past half hour. And then again, read it yourself. The first 2 idea is just the G versus G sub C. You all know that. Do I have to go through that one more time? Right? You want to? Okay. So G is what? G sub C is what? Which one is gravity? G is acceleration due to gravity. What's the unit? What's the value for, say, SI? 9.8 watts. Any question on that? Does it change between the Earth and the Moon?
Yes.
Definitely. Right? It's location dependent. What is G sub C? What does it really mean? If I put the short question and ask, tell me what's G sub C, what would you say?
Proportionality constant.
Wait, that's what I want to hear. Proportionality constant. It comes about because F is proportional to MA. F is not equal to MA. So what's G sub C for SI unit? 1. What's G sub C for English? 32.2, the appropriate unit. Right? And that's what we have done for the last quiz. So if you have done it, you know how to handle G and G sub C. Okay? Any other question? Yes?
So when exactly do you use G sub C? Is that going to be any time you're using English units and you're dealing with forces? Or?
So that's a question that a lot of you have the same problem with. When do I use the G sub C in the English unit? Even for me, I don't know a priori. So what do you do? What do you do? You always carry the unit in your final calculation. Like the quiz I went through this today, the one you had last time. You write out all the terms. At the final calculation, where you use your calculator, you always carry your unit. If the unit doesn't work out, what do you think you're missing? The G sub C. Do you know numerator or denominator? I don't know. I let the problem tell me. That's the only way you know for sure you're not missing the G sub C. Right? It's a poor man answer or poor woman answer, but it works. The bottom line is anything with more forces, pressure, force, you need a G sub C because of Newton's second law. Right? You may forget that, that's fine, but you do not forget the factor of 30. If you carry the unit, you won't miss. Same with SI, you can miss a factor of 1,000. But if you carry the unit, that will never happen. Okay? Other question? Yes?
In the test, we specified if you're talking about pound mass or pound force.
No, the question is if I say pound, LB in the test, what would you assume that to be? Pound force. That's how I work in industry. Pound mass will always spell out. Okay? And that's the same with all the homework problem you have seen. Yes?
Do you want us to write out what we used to get the answer? So like when you wrote the things down there, you wrote continuity and you wrote whatever, like you used the name of the equation that you used for your answer. Do you want us to list that too?
I like to, that again, if you mess up on your math or algebra, at least you get partial credit by saying this is continuity, this is permeability, this is momentum. Right? What else? Yes?
Should we mark down like the density of water? That's
You can put down anything you like. I mean, as I said, you have your formula sheet. If you want to, put it down. Right? Yeah. Yes?
Are there specific values for the density of water you want us to use? I know it can be.
I would tell you, most of all the problem in the test, the property of the fluid will be given to you. Viscosity, density, should be no effort for you to, you should not have to look at it. Right. Okay? Other questions? So on the review sheet, the next one is continuity, which we already went through today. And so the quiz is perhaps a good time to revisit it. The first part asks you, term 1, in mass, length, and time. So density is mass, length, cube, right? What's the differentiation with time? In mass, length, and time, what's this equivalent to? You have to think. Anyone have a question? All set? All good? That's all it is. What about, in the quiz, it says dV. So is this the velocity? No, what is it? What is the unit? Altitude. So the answer is mass per unit time, which you should show this, just so I know you know how to do it, but you know the answer. It's mass per weight. Every term, and then second and third part asks you the other two terms. You don't have to go through the same analysis thing. You just say common sense. It's mass per unit time. Right? You don't have to go through the same analysis. Questions? So physical meaning, we went through that many times. This is weight of what? Change. Go on. Of mass in control volume. I'm looking for one more word to get you the full credit. Increase. Yeah. It's an increase. It's an increase. We went through that many times. This is just a recap. Right? The other two terms, 2 and 3, is simply mass flow weight. Out minus mass flow weight. In. And the plain layman description is the continuity, just say there has to be a balance of rate of change of mass increase in my control volume by the mass flow out, mass flow weight out, and the mass flow weight in. So you have to create and destroy mass. That's what I'm looking for, which we have went through in the lecture many times. So it's nothing new. Any question on continuity? The formula sheet just reminds you of the dot product of Can you recognize all these? You want to go through that? One, very good. So then we went through the linear momentum, which we just did by way of the homework due today, forces in the x direction, so on and so forth. So I let you again to read that on your own, how to deal with pressure that is always inward and normal, not double counting the sign on the m dot in the momentum equation. We went through that series of times. And when in doubt, go back to the two-dimensional plate problem, because that's very insightful and instrumental, help you to put everything in perspective. And then the last bottom of that review sheet is just the Bernoulli. Questions? We're done with the review. Yes?
Just like Bernoulli in simple English.
Bernoulli in simple English. Let's try that. Fair question. There's not anything shattering, but it's just a simple reading of each of the terms. So what Bernoulli says, along a streamline between 2 points, there has to be a relationship between the pressure, static pressure. All right, and you know how to measure static pressure by the pedal flow. And the dynamic pressure, half V squared, and it's a function of the speed. And the gravity, rho GH, the pressure due to that gravity term. Add them all up, they must be a constant. So when the static pressure dropped, like we did with that car in the wind tunnel, as the flow accelerated from 0 miles per hour to 60 miles per hour, those sums must maintain a constant. That's all it said. That's all it said. Yes?
Could you look at it like energy of the flow?
So that will be something we do in a month. And my precursor for that is please don't mix Bernoulli with energy. So the answer ahead of time is no. We will do an energy equation later. It's very easy to mix them. Even the book does it, but I don't agree with that. So we'll defer that until another month. Okay? So just a few comments on introduction to fluid, which is something should be done on the first lecture, but we do a deep dive on continuity. So let's just say a couple of questions in everyday life relating to fluid. Now, why, besides trying to get to be a senior next year, what are the reasons to study fluid, the motivation? So I'll give you some examples. Any golfer here? And people play golf? People play golf? That's it? You don't have to lie. So why are there dimples on the golf ball?
Fly straighter.
Straighter? No, it fly further, not straighter. So we're examining why. And they're different shaped dimples. And they charge you more for what they thought is more, carry more distance. That's fluid mechanics. The second one you have already seen by way of example, a hydraulic jump. Putting a dish under the water faucet and see how the water spread, and you see the water level jump. That's like a shock wave. It's equivalent to an F-15 at Langley Air Force Base going supersonic. And there's a sudden jump, tremendous jump of pressure, just like that water level rises, but now in air. And that shock wave will pierce your ear, hurt you. That's fluid mechanics. The third one, some of you have seen it from 2124. And we will have homework deal with that later on also. How can an airplane take off? How would an airplane moving down the runway eventually take off? How do you generate vertical force called lift? Anyone who have read Popular Mechanics? Or things of that nature can answer that? This from Bernoulli. By accelerating faster on the upper surface of the airfoil, I reduce the pressure more, just like the car in the wind tunnel. It's more, much lesser pressure on the upper surface than lower surface. So the delta P is generated. Look at that by way of Bernoulli. Any fishermen or fisherwomen here? Right? So why is fish as this shape? When was the last time you caught a fish that looked like this? This is called streamline. It took millions of years of evolution. So the flow around the fish stay catch. And that's reducing drag. So it's very difficult to catch a fish with a bad end. That's fluid mechanics. There's some that we don't have time to go through, but you can read it from, or you can find the answer on Google. You know, any baseball, softball player here. So you want to ball the spin, what do? You want to ball the drop, what do? You put different top on the ball. That's fluid mechanics. The ball cutting through air, due to the spin you put, can have different trajectory. Any football player here? So you when toss a long ball, why do you put spiral on the ball? If it doesn't, what will happen to the ball? It will be wobbly. It's not stable. So that small spinning motion help to make the ball stable and follow the path. That's fluid mechanics. But that's beyond what we can do. That will be more advanced classes. Into the beach in the summer, if you stand on the edge of the ocean, where there's sand underneath you, but also water, wave coming in, as the wave comes towards you and then be street back out, ever feel the sand around your foot is eroding? No? You're too busy looking at other things? That's fluid mechanics. The same as the tall building on a windy day in the fall when the tree leaf. You walk back to your dorm and you see those tree leaves swirling. Those tree leaves telling you the flow of the air. It's actually like a tornado. That's fluid mechanics. But that's again beyond what we can cover. And some of those are applications to engineering problem like flow in a gas turbine, etc., etc. That's just some example of everyday life example that to get you excited. So for the last 3 minutes, I just want to look at the roadmap of where we'll be heading for the next 2 months. So we start, or now finish, a very interesting introduction. The study of fluid can be divided into 2 parts. The first part, which is what we have done for the past month, is analysis. How do I analyze the flow? Approaches. Given a nozzle with a elbow and so forth, how to analyze the anchoring force. And for that, we use so-called control water. It's a global, big picture average approach. Example, the gas turbine engine on the hallway. I want to calculate the force or the thrust generated by air being sucked into the engine and add fuel, control explosion in the combustor, and then a hot jet coming out. Tell me how much force I can generate. 90,000 pounds. And really, what we have done for the past month, a very simple control on. Don't care the detail inside, just very quick analysis on the back of the envelope. That's not going to cut it. You want to get a job at General Electric designing gas turbine. Next area, starting with the Bernoulli, is I want to look at detail inside that engine. So I'm going to set up what I call a differential analysis, where instead of a global approach, I'm going to look at dx, dy, dz in 3D, and formulate a continuity equation and the momentum equation. And I'm going to solve it on this match. And outcome all the details you want to know within the flow field. So that's analysis 2. The third one is experimentation. All right, I have done all my analysis. Some backup envelope, 10 minutes, some a month, or 3 years, or PhD student dissertation. How do I know I'm right? Well, you do experiment. And you don't do it by building a billion dollar 787 Dreamliner from day one. Because if you're wrong, the company will go toilet, gone. So you do simulation experiment, like we do here in the Randolph. It's called dimensional analysis. So the next month, we will go for differential analysis and dimensional analysis. The other roadmap is separating or pretending the flow to be simplified by starting with no friction, and that is how we have the Bernoulli equation. So next time, on Thursday, we'll show you how the equation comes about by assuming no friction. Then for the last 3 weeks of the semester, we will head on deal with friction, viscosity. How would that change our analysis of the flow by also subdividing that into 2 categories, which is internal, that's flow in a pipe, for example, and external, that's flow over an airplane, as an example. By including viscosity, how will I analyze the problem differently? And that's where we talk about so-called boundary layer, the no-slip condition, and that change everything. You can't use Bernoulli anymore. Okay, good luck with the test tomorrow. And class will resume on Thursday, don't forget, we will have regular class.